Assalamualaikum. I hope you all are fine and safe at home. Welcome back to my channel. Today we will study chapter number 11, Thermochemistry. In this chapter only two topics are included. First, Hess Law and Born-Haber cycle. We will study both of the topics. First of all, we should know about thermochemistry. What is thermochemistry? Thermo means heat, means there are heat involved. Branch of chemistry that deals with study of heat involved in a chemical reaction. This is called thermochemistry. Then we are moving towards the Hess Law. In Hess Law, what question it came in exam? Define and explain Hess Law. It came for the short question for 3 to 4 marks, and we have to firstly we have to write the definition. Then explanation with diagram. Then example. This 3 points you have to explain for the Hess Law. G.H. Hess states Hess Law in 1840. The first point is definition of Hess Law. So definition is, it states that the enthalpy change is same whether the reaction take place in single step or multiple step. Whether the reaction take place in single or several steps. This is the definition of Hess Law. Second point is explanation with diagram. So first I will draw the diagram. This is A part, A reactant. Suppose this is A reactant which converts into product B, and this is initial stage and this is final stage, and here is enthalpy of formation included. Then we take second step, A converts to C, then D, and D converts to B. Here enthalpy of formation first included, then enthalpy of formation second, then enthalpy of formation third is included. So we take 3 steps to go to the product B, and this is single step. So enthalpy is a state function. Enthalpy change is a state function that enthalpy change from going to initial stage to final stage, from stage A to B is independent of path follow. Is
independent of path follow. So
it does not depend that take the single step or the multiple step. Enthalpy is a stage function. We discussed that enthalpy is a state function. Enthalpy change from going to initial stage, this stage A, to final stage B is independent of the path followed. So firstly we discussed this point. Then now we suppose that reactant A. We suppose this as reactant A. Suppose
reactant A converts
into product B. This is in one step. You can see A to B is in one step. Is in one step. So enthalpy of formation is included here. In this case we are included with the enthalpy del H. Now if we suppose the enthalpy change in 3 steps.
In 3 steps.
Means A to B is a single step in which del H is included. Then A converts to C and C converts to D and D converts to A. Here is enthalpy H1 included. Enthalpy change H2 is included. Enthalpy change H3 is included. So 3 steps. 3 steps involving reactants. What reactants? A, C, D and B is the product. A converts into B, A converts into C, then C converts into D and D converts into the product B. This cycle pursue. A converts into C, C converts into D and D converts into B. Enthalpy 1, enthalpy, change in enthalpy 2 and change in enthalpy 3 are enthalpy change in a chemical.
Enthalpy change
These steps. Then according to Hess's law del H, this enthalpy of formation del H is equal to change in enthalpy is equal to change in enthalpy 1 plus change in enthalpy 2 plus change in enthalpy 3. This is Hess's law. And then you have to give an example, which is the third point. Example you can give in the exam. It is better for you to get maximum marks. Combustion of carbon to CO2, carbon dioxide. First reaction is carbon plus O2 gives CO2. You have to mention the states is very important, otherwise it will be wrong. Then enthalpy of formation is included, which value is minus 393 kilojoule. 5 minus 393.5 kilojoule. Then second reaction is Here carbon is in the form of solid and oxygen in the form of gas. Then carbon in the form of gas plus half of oxygen gives carbon monoxide, which is a gas. And here enthalpy is included, which value is minus 110.52 kilojoule. Then third reaction is carbon monoxide is a gas plus half of oxygen gives carbon dioxide. And the enthalpy is, here it is gas and this is also gas. And the enthalpy include is, this is enthalpy 1 and this is 2. Its value is minus 282.98. Now this is equation number, this is one equation, this is second, and this is third equation. Adding 2 and 3, we get, adding this two equation, we get, you can see carbon monoxide is cancelled from here and this half is cancelled from here. We are left with carbon and oxygen and carbon dioxide, means C plus O2 gives CO2. This is solid, gas and gas. And if we add minus 110.52 plus minus 282.898, then this is like this, del H is equal to del H according to the Hess law, which we studied above, del H2. We add this both to get this result and we will get this result, and by adding them we get minus 393.5 kilojoule is the answer. So in this way you can write the example, or you can show the diagram as well. First we will draw an arrow which is change in enthalpy. Here carbon dioxide plus, first reaction is carbon dioxide in the form of solid plus half plus O2 gas gives us carbon dioxide. In this way you will draw a line and show the arrow, and enthalpy is included, which is minus 393.5 kilojoule. Then second reaction is, you can draw a line here also, carbon dioxide in the form of solid plus half of O2 is a gas. This gives us carbon monoxide, CO, which is also a gas, and its value is, enthalpy value is minus 110.52 kilojoule. And then carbon monoxide plus half of oxygen reacts to give us carbon dioxide, this arrow. Enthalpy change, this is 1 and this is 2, which value is minus 282.98 kilojoule. So this is the energy cycle. This is energy cycle. I'm showing you again. First of all, you will write the definition, which is enthalpy change is same whether it take place in the single step or several steps. This is same whether it takes in the single step or this multiple step. like from A to C, then C to D, then D to B. This is several steps, second step, multiple step, and A to B is single step. Then explanation. Suppose a reactant A which converts into product, this is single step. And if we suppose enthalpy change in 3 steps involving reactant A, C and D. A converts into C, and C converts into D, and D converts into B. And enthalpy change in 1 and 2 and 3 are the enthalpy change in these steps. Then according to the Hess's law, del H is equal to del H1 plus del H2 plus del H3. This is equal to del H1. And example is like this: combustion of C to CO2. First reaction is carbon reacts with oxygen to give carbon dioxide. Enthalpy is this. And half of oxygen gives CO, carbon monoxide. Enthalpy is this. And carbon monoxide reacts with half of oxygen, gives carbon dioxide. And by adding equation 2 and 3 we get carbon plus oxygen gives carbon dioxide. And energy diagram you can show it like this. So this is all about the Hess's law. Now moving towards the Born-Haber cycle in the next video. I hope you all like this video. Thanks for watching. Allah Hafiz.